This is a brief video on how to determine whether your test is significant or not. It doesn't matter which test you're using. Any of the three t-tests, an ANOVA, Pearson R correlation, chi-square, any of the tests still have the same basis. You have your test statistic, and you have your critical value, or a p-value, that is the probability where the critical, or the p-value is the probability value of where your test statistic falls, which is what you would compare to your alpha level. So let's just look at this at the most basic way. So I've drawn the distribution, and as you can see, I have these lines here, here and here. These are basically the boundaries. So whatever your alpha level is, you look up for the critical value in the back of the textbook. These are the boundaries. So this is where the cutoff is, where you start looking at things being significant. So right at this line is a critical value. It could be a T crit, it could be an F crit, it could be your R crit, or your chi-square crit. No matter what test you're using, this is the basis of it, the overall basis. And this is based upon your alpha level. So at this point is this boundary. So on this side of your distribution, this middle area, this is the largest area. This is where we would see normal scores fall. So this is where just the majority of scores fall. The average scores fall in that area. So any test statistic that falls in that area is not significant. So this is where you retain that null, okay? The only time your test is significant is if your test statistic falls beyond that critical boundary. So that critical value is the boundary. That's the line where it says, okay, nothing is significant until it falls out in those tells. So in this area, anything from here out or here out, these are significant. So any test statistic, it could be your F, your R obtained, your chi-square obtained, whichever one, you're going to be comparing it to see, does it fall further out into the tail than your critical value. Now, just as I had created the video on comparing P to alpha, this is very much related, because anything in this large area, anything here is going to be, if there's a p-value, it's going to be larger than your alpha. Anything in that area is going to be larger than the alpha level. But anything in these areas, the p is less than alpha. Because look at the size of the tail. It's smaller. It gets smaller and smaller, right? So your p-value is, the probability value is going to be less, where probability in this area is much higher. That's more likely. So this is all based on looking at your t-value compared to your t obtained compared to your t crit, or your f obtained compared to your f crit, or your r obtained compared to your r crit, or your chi-square obtained compared to your chi-square critical value. No matter what, this is how we're telling whether it's significant or not. So ultimately, if we're using a t, our t obtained, and I'm going to say the absolute value, is greater than our t critical value to be significant. Our f obtained is greater than our f crit. We don't need to use an absolute value for that because I'm going to circle this in red because anything in red is talking about, on the outside is talking about it being significant. Anything with F is positive because F obtains are only positive and F crit is only positive. And R obtained, the absolute value, is larger than your R critical value. And I'm going to write it up here at the top. Your chi-square obtained is always larger than your chi-square, if I can get it to write, critical value. And those are always positive as well. So no matter what, the obtained test statistic, the absolute value of that is going to be larger than the absolute value of your critical value. It's further out in the tell. So this is how you tell whether something is significant or not.